3.1 Quadratic Functions and Models. A polynomial function of degree n, where n is a non-negative integer, is a function of the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, continuing the pattern, a sub 1 x plus a sub 0, where a sub n minus 1, a sub 1, a sub 0 are complex numbers with a sub n not equal to 0. If you're given the polynomial function f of x equals 2, that's a constant function because it's like y equals 2, and it's a horizontal line. So this is a constant function. It has degree 0. The leading coefficient would be 2. If it was f of x equals 5, the leading coefficient would be 5. F of x equals 5x minus 1. This is linear. It has a degree of 1 because x is to the first power. The leading coefficient would be the number in front of that variable with the degree, so it would be 5. F of x equals x squared minus x plus 1 would be a quadratic. It would have a degree of 2 because it's x to the second power, and the leading coefficient would be 4. F of x equals 2x cubed minus 1/2 x plus 5 is a cubic function. It has a degree of 3 because the highest exponent is to the third power, and the leading coefficient is 2. And then x to the fourth plus the square root of 2x cubed minus 3x squared would be quartic. It is a 4th degree polynomial, and the leading coefficient would be 1. A quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are complex numbers and a is not equal to 0. We're going to graph by plotting points and also by using our transformation. So remember, if we have f of x equals a times x minus h squared plus k, this is our vertex form of a quadratic equation. So if a is positive, it opens up. If a is negative, it opens down. A gives us a vertical stretch or a vertical shrink or compression. We have a horizontal shift to the left or right, and then our vertical shift up or down. So for example 1, graph each function, give the domain and range. So there's a couple ways we can do this. We're going to start by plotting points, and then we'll also learn how to convert it to vertex form. All right, so to plot points, we're going to make an x and y table. And we can pick values for x to plug in and find out what the y values are. So we can start out with just like -2, -1, 0, 1, 2, and then see if we need to add any points to that. So if I plug in a -2 for x, that gives me -2 squared is 4, minus 4 times -2 is 8, minus 2, 12, 11, 10. And then if I plug in a -1, -1 squared is 1, -4 times -1 is plus 4, minus 2, that would be 3. 0 would be -2. 1 squared is 1, minus 4 times 1 is 4, minus 2, that would be -3 minus 2 is -5. 2 squared is 4, minus 4 times 2 is 8, minus 2, so that would be -4, -5, -6. So let's plot these points and see what we have so far. We do know that it's a quadratic, which means we know that it should be in the shape of a parabola. So -2, 10, negative 1, 3, 0, negative 2, 1, negative 5, 2, negative 6. Okay, so I can see I haven't found my vertex and started going up yet. So let's continue this. 3 squared is 9 minus 12 minus 2, negative 3, negative 5. Okay, and then from here, I know if it's a parabola that I'm going to have reflection points. So I can just find the other points by the reflections of the points that I found. And then give the domain and range. So the domain would be negative infinity to infinity, and the range would be from negative 6 to infinity, and negative 6 is on the graph, so it would be a bracket. All right, so for this next one, B, we're going to graph g of x equals negative 1/2 x squared. We're going to compare it to y equals x squared and y equals 1/2 x squared. So first, let's graph that parent function, y equals x squared. So negative 2, negative 1, 0, 1, 2. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared, 1 squared, 2 squared. Okay, so this is y equals x squared. And then to graph y equals 1/2 x squared, we can multiply our y values by 1/2 using transformation. So it's a vertical compression. It multiplies the y values. So negative 2, 2. Negative 1, 1/2, 0, 0, 1/2, 2, 2. Okay, so a vertical compression or a vertical shrink made my graph get wider. And then to graph y equals negative 1/2 x squared, we would multiply the y's by negative 1/2. So negative 2, negative 2, negative 1, negative 1/2, 0, 0, 1, negative 1/2, 2, negative 2. All right, so y equals negative 1/2 x squared is a reflection over the x-axis, a vertical shrink by 1/2. And then the domain would be negative infinity to infinity, and the range would be negative infinity up to 0. All right, and then C is f of x equals negative 1/2 times x minus 4 squared plus 3. Compare it to the graph in part B, to the final graph, the y equals negative 1/2 x squared. So we have that graph, and we're going to shift it to the right 4 and up 3. And then we're going to graph that same table because we have the reflection over the x-axis and the vertical shrink by 1/2. So from here, we can go negative 2, negative 2, and then negative 1, negative 1/2, 0, 0, 1, negative 1/2, 2, negative 2. So compared to the graph in part B, we had a horizontal shift to the right 4 and a vertical shift up 3. And the domain for this graph would be negative infinity to infinity, and the range would be from negative infinity up to 3. Okay, using completing the square, give the equation in vertex form. So to convert a standard form quadratic equation to vertex form, we're going to complete the square. The first step is we're going to take this constant and we're going to move it over. So f of x minus 7 plus blank equals x squared minus 6x plus blank. Alright, it is important that you don't lose your f of x. If you want to change it to a y, that's okay, but it shouldn't get lost. It shouldn't be set equal to 0, because setting it equal to 0 is finding the x-intercepts, and that's not what we're doing. We're converting it to a different form of an equation. Okay, so don't lose your f of x. Alright, then we're going to complete the square. We're going to take the b value and divide it by 2. Negative 6 divided by 2 is negative 3, and negative 3 squared is 9. So we're going to add that to both sides, and then simplify. So f of x minus 7 plus 9 simplifies to f of x plus 2, and x squared minus 6x plus 9 factors to x minus 3 squared. And then to get f of x equals, to get it by itself, minus 2 on both sides. So f of x equals x minus 3 squared minus 2. Okay, give the coordinates of the vertex as an ordered pair. So the vertex would be at 3, negative 2. And then give the equation of the axis of symmetry. That would be x equals 3. Make sure you write it as a whole equation. Don't just write 3. It's a line, so it needs to be the equation of a line. Find the intercepts if they exist. Write as an ordered pair. So the y-intercept would be when x equals 0. So if I go back to the standard form and plug in a 0 for x, I get 0 minus 0 plus 7. So the y-intercept is 0, 7. The x-intercepts can be found by setting y to 0. So I'm going to go back to the original equation, x squared minus 6x plus 7, and set it equal to 0. So if I can factor it, I'll factor it. Which this one doesn't, because that would give me a minus 8 in the middle. And if I changed one of the signs, it would give me a times negative 7. So if it doesn't factor, then I can either complete the square or use the quadratic formula. So since a is 1 and b is even, it's pretty easy to complete the square, so I'm going to go ahead and do that. If you prefer quadratic formula, that's fine also. So x squared minus 6x plus blank equals negative 7 plus blank. Divide by 2 is negative 3, squared is 9. So x minus 3 squared equals 2. And now we're solving for x. So this is where it's different than converting the form. I'm solving for x when it's set equal to 0. So x minus 3 equals plus or minus the square root of 2. So x equals 3 plus or minus the square root of 2. So that means I have two intercepts, 3 plus the square root of 2, comma 0, and 3 minus the square root of 2, comma 0. Okay, I know that the graph will open up because a is positive. Alright, so I can go ahead and make my table. So my parent function table, negative 2, negative 1, 0, 1, 2, 4, 1, 0, 1, 4. There's no multipliers. I've already marked my starting point, so from my vertex or my anchor point, I'm going to go -2, 1, 2, 3, 4, -1, 1, 0, 0, 1, 1, 2, 4. Okay, the open interval of the domain for which the function is increasing. So if I trace it from left to right, it's going to increase from 3 to infinity. And they're parentheses because it's an open interval. And it decreases from -infinity to 3. The domain is -infinity to infinity. And the range is -2 to infinity. For a reflect question, explain how to determine whether a quadratic function opens up or down. So take a minute and answer that reflect question in your own words. Example 3, using completing the square, give the equation in vertex form. So we're going to start by moving the constant over. So f of x minus 1 equals -3x squared minus 2x. Now notice I didn't add my plus blanks yet. That's because a is not 1, so I have to factor that out first. So factor out the -3, that gives us x squared plus 2/3 x, and then add your plus blanks. And then on the other side, f of x minus 1 plus blank, but in this blank, whatever you add in it is going to get multiplied by -3 because that -3 is going to get distributed to the blank on the other side. All right, so divide by 2, so 2/3 divided by 2 is 1/3, squared is 1/9. And then the right side would factor to -3 times x plus 1/3 squared. And the left side would simplify to f of x, and that would be -3 times 1/9 is -3/9, -1/3. And then -1 is the same thing as -3/3. So f of x minus 4/3 equals -3 times x plus 1/3 squared. So f of x equals -3 times x plus 1/3 squared, and then plus 4/3. All right, so give the coordinates of the vertex as an ordered pair. That would be -1/3, 4/3, and the axis of symmetry would be x equals -1/3. So -1/3, 4/3 would be about here. Notice that the graph is a little bit, it's rescaled, it's every 0.5. Okay, and then find the intercepts if they exist. So I can find the y-intercept by plugging a 0 into x. The standard form would be the easiest. It would be 1. And then for the x-intercept, work is required because you have to use a quadratic formula or factor or complete the square. So I like to go back to the original instead of using the vertex form that I found, only because if I made a mistake on the vertex form, then I'm finding the intercepts from something that's not correct. So I go back to the original. So -3x squared minus 2x plus 1 equals 0. I've already completed the square, so if I'm comfortable with it, I can. Honestly, with all those fractions, I would prefer to use a quadratic formula. So x equals -b plus or minus the square root of b squared minus 4ac over 2a. That's going to be 4, and then it's going to be a plus, because I have a minus 4 times a negative 3. It's going to be a plus 4 times 3 is 12. 16, 2, plus or minus, the square root of 16 is 4. And this means this could have just factored. So 2 plus 4 is 6 over negative 6 is negative 1. And 2 minus 4 is negative 2 over negative 6 is 1/3. So negative 1, 0, and 1/3, 0. So negative 1, 0, and 1/3, 0. Okay, and then I also know that the y-intercept is 0, 1. And I know that it's going to have a reflection point. So it's going to be reflected over the axis of symmetry. So it's going to be maybe about here. Okay, so because of us having like all these fractions, I'm not going to make my table for this like I normally would. I have enough points here from the information given that I can just graph my parabola. So with the vertex, the x-intercepts, the y-intercept, and the reflection, that gives me my 5 points that I need to graph. Okay, the graph opens down because a value is negative. I've already graphed it. The open interval for which the function is increasing, so tracing it from left to right, it increases from negative infinity to negative 1/3, and it decreases from negative 1/3 to infinity. The domain is negative infinity to infinity, and the range is from negative infinity up to 4/3. Okay, so explain how to determine the x-intercepts of a quadratic function, and then explain how to find the y-intercepts. So for x-intercepts, let y equal 0, and then solve for x by factoring, completing the square, or quadratic formula. For the y-intercept, let x equal 0 and solve for y. Right, the vertex formula. The vertex form of f of x equals ax squared plus bx plus c is given by f of x equals a times x minus h squared plus k. It is not necessary to memorize the expression for k because it is equal to f of h, which is equal to f of negative b over 2a. The quadratic function f of x equals ax squared plus bx plus c can be written as y equals f of x equals a times x minus h squared plus k, where a is not equal to 0, and h is equal to negative b over 2a, and k is equal to f of h. So this is your vertex formula. And it is something that you should memorize. The graph of f has the following characteristics. It is a parabola. with a vertex HK and the vertical line x equals h as its axis. It opens up if a is greater than 0 and down if a is less than 0. It is wider than the graph of y equals x squared if the absolute value of a is less than 1, and narrower if the absolute value of a is greater than 1. The y-intercept is f of 0 equals c. The x-intercepts are found by solving the equation ax squared plus bx plus c equals 0. If b squared minus 4ac is greater than 0, then the x-intercepts are negative b plus or minus the square root of b squared minus 4ac over 2a comma 0, or you can factor or use completing the square to solve for x. If b squared minus 4ac is equal to 0, then the x-intercept is negative b over 2a comma 0. If b squared minus 4ac is less than 0, then there are no x-intercepts. So if you solve for x, if you get imaginary values, then you need to write none for x-intercepts. So the imaginary values would be solutions to the equation, but they would not be x-intercepts, because x-intercepts means that that the graph crosses the x-axis at those points. If they're imaginary, then the graph is not crossing it. So for the x-intercepts, you would need to write none if they're imaginary. So example 4, find the axis and the vertex of the parabola having the equation f of x equals 2x squared plus 4x plus 5. So we can complete the square like we have been doing. So there's two ways to do this. Completing the square, or vertex formula. So we'll do both, and you would get to use whichever one you think is easiest or whichever one makes the most sense. All right, so completing the square, we would write f of x minus 5 equals 2x squared plus 4x, and then we would factor out the 2, x squared plus 2x plus blank, and f of x minus 5 plus 2 times blank. Then complete the square, divided by 2 is 1, 1 squared is 1. So f of x minus 5 plus 2 is minus 3, 2 times x plus 1 squared. So f of x equals 2 times x plus 1 squared plus 3. They want us to find the axis and the vertex. So the vertex would be negative 1, 3, and the axis of symmetry would be x equals negative 1. All right, so now let's use the vertex formula. We would do h equals negative b over 2a So b is 4, so negative 4 over 2 times 2 is negative 1. And then to find k, we would plug negative 1 back into x. So it would be 2 times negative 1 squared is 1, plus 4 times negative 1 plus 5. Two minus 4 is negative 2 plus 5 is 3. So the vertex would be h, k, and the axis of symmetry would be x equals h. So negative 1, 3, and x equals negative 1. So we get the same thing either way, it's up to you which one you want to use. So the vertex formula comes in handy when we're doing application problems and a is like negative 16, and we don't want to factor out a negative 16 to complete the square. So just kind of depending on what the equation given is and what you're asked to do, you can use whichever one's easier.